Section 4.1 exercises. Problem 1. We were given an exponential function that models the average amount spent in dollars at a shopping mall after X hours of shopping. We want to know what is the average amount spent after 3 hours of shopping. So we are given here in this problem the value of X being 3 and asked to find the value of Y. Y is the functional value at 3 hours of shopping. So f of 3 means to replace the x in the function by 3. So we'll have 42.2 times 1.56 to the third power, and that will give us approximately 160.2. So we will round that to the nearest dollar. $160 is the average amount spent after 3 hours of shopping at the mall. Problem 2. We're asked to graph the exponential function 3 to the x. Okay, here we're going to use standard form for exponential functions. Y is equal to b to the power x. And since the value of b, in our case, is greater than 1, here the value of b is 3, then we will have a graph shape of this form here. This is an increasing exponential function. Okay, so let's determine a few ordered pairs to make the graph more accurate, and then we'll plot those points and we'll have the graph of the function f of x. So we'll make a table of values for x and f of x. And we'll take x values to be -2, -1, 0, 1, and 2. And to obtain the y coordinates, we'll take 3 to the power of x. So 3 to the -2 becomes 1 over 3 squared, or 1/9. At -1, we have 3 to the -1 power, or 1 over 3 to the first power. 3 to the 0 is 1. 3 to the first power is 3, and 3 to the second power is 9. If we transpose those ordered pairs to the coordinate system, we'll have -2 giving -1/9. It's difficult to put here, approximately there. And -1 is a little higher at 1/3, and 0 gives the y-intercept of 1, and 1 gives the y value of 3, and finally 2 gives a y value of 9. So there are our points plotted, and then we'll connect those points with a smooth curve and draw a graph of the function f. And here, note that we have horizontal asymptote to be y equals 0, which is the x-axis. And the graph increases forever upward like that. Let's go on to problem number 3. We're asked to use the graph of the function 3 to the x that we just graphed to obtain the graph of a new function, g of x, equal to 3 to the x minus 1 power. So here, g of x is f of x minus 1. And that would give us 3 raised to the power not x, but replacing x by x minus 1. And that's what the function g of x is. This is a horizontal translation. And that'll be 1 unit to the right. So what we'll do is we'll add 1 to each x coordinate. So what we'll do is we'll get the ordered pairs here for f of x. These are the ones that we had before. -2 giving us 1/9. -1 is 1/3. 0 is 1, 1 gives 3, and 2 gives 9. Then we'll add 1 to each x coordinate. The y coordinates will be the same, and we'll add 1 to each x coordinate. So here, -1 will give us 1/9. -1 plus 1, 0 will give us 1/3. 0 plus 1, 1 will give us 1. And 1 plus 1, 2 will give us 3. And 2 plus 1, 3 will give us 9. Now we try to plot these points down below, and we'll obtain the graph of both. So -2, -1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9, about there. And we'll draw that graph. That is our f of x graph. There. So that is f of x there. Plot the points for g of x. -1 gives us -1/9. Easier to move from the positive values here. 1 gives 1 right in here. 2 gives 3 right here. And 3 gives 9 here. You can see that each of these coordinates has moved to the right by 1 unit, and that will give us the graph here of g like that. So that's g right there. Slid 1 unit to the right. And both have horizontal asymptotes at y equals 0. Let's go on to problem number 4. Use the graph of the function 2 to the x to obtain the graph of a new function 2 to the power x plus 1. Okay, so here, g of x is f of x plus 1 more. And that represents a vertical, I like to call it a lift, 1 unit up. So what that means to take 1 unit up is, so we add 1 to each y coordinate. So we'll quickly list the y coordinates and x coordinates for the function f, and then we'll add 1 to each y coordinate to get the coordinates for g of x. So -2 gives us 1/4, -1 gives us 1/2, 0 gives 1, 1 gives 2, 2 to the second is 4, and 2 to the third is 8. And then for the function g of x, using the same values of x, we now add 1 to each y coordinate. So 1/4 plus 1, 1/2 plus 1, 1 plus 1, and 2 plus 1, and 4 plus 1, and 8 plus 1 is 9. Okay. So graphically, I'm going to draw the graph by hand here. The graph of f of x will cross through the y-axis at 1 unit high, be an increasing exponential function, and asymptotic to the x-axis as before. So that's f of x. We'll draw g of x in black. G of x has a much higher y-intercept of 2. And it's lifted 1 unit up, so all points are 1 unit higher. So in a sense, it remains parallel to the blue function f of x. But its asymptote is lifted up as well 1 unit. So instead of y equals 0 for the function f of x, we will now be at y equal 1 for the horizontal asymptote for g of x. So this is f, and this is g. And you can see this is not a slide, but an actual lift upward by 1 unit. Let's go on to problem number 5. sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years if we have quarterly compounding. So here we'll use a compound interest formula. The amount in the future is given by the starting amount, the principal P, times 1 plus the interest rate R divided by N, which is the number of compounding periods in a year, raised to the N times T. T represents time in years. So here to calculate the value of A, we're given $10,000 to begin. That's our starting principal, times 1 plus. The R in the formula is the interest rate as decimal, so 0.08 is 8%. Quarterly compounding means 4 times a year, and the power will then be 4 times 5 years. So working this through 10,000, 0.08 divided by 4 is 0.02 plus 1, so that's 1.02. 4 times 5 is 20, and working this out on the calculator, we always round to dollars and cents. We'll have $14,859, and rounding to the nearest cent, 47 cents. And there is the amount in the account after 5 years with quarterly compounding at 8%, starting with $10,000. Move on to problem 6. We now have continuous compounding, and this requires a different formula, which is the continuous compounding formula, which uses the exponential number e. Still remains to have A, the future value, P, the present or the starting amount, and R as the interest rate as decimal, and T is still the time in years. So all that changes is we have the exponential number e there. Interest rate is 0.08 or 8%, and the time given is 5 years. So working out some of the arithmetic here, 10,000. This will give us e to the 0.4, and again, rounding to nearest cent will give us $14,918.25, and that's in dollars. And again, rounded to the nearest cent. Okay, problem number, well, that concludes the exercises for set 4.1.